All right, this is part 2. Find the regular heptagon with sides equal to 16. So we know a heptagon is 7 sides. So we just have to do 16 times 7 to find the perimeter. So 16, which is the side length, times 7. So 16 times 7 is 112. Okay, so in a heptagon, we're going to find the central angle, 360 divided by 7. Which is going to give you about 51.4. Then when we look at our triangle, so this is the little triangle right here. Remember, inside of this little triangle is half the central angle. So if we divide that by 2, that's going to be roughly about 25.7 degrees. And we know that half the side is down here, so that's going to be 8, which is half of 16. We just need to find the apothem. So to do that, we're going to use O and A with our googly eyes up here. So that's going to be tangent. So we're going to get the tangent of 25.7 equals opposite over the apothem. And we can switch those two spots. Let's see, can I write over here? Oh, sweet. I didn't mean to write that though. So we'll switch those. We're going to get apothem is equal to 8 over tan 25.7. So 8 divided by tan 25.7 is going to give us 16.6. So we get 16.6, multiply those two together, divide by 2. So we'll get the area is equal to 1/2 16.6 times 112. And we're going to get 929.6. All right. If the perimeter of a rectangle is 24 and the area is, I cannot see, is 27, find the base and height. Okay. I looked. There's no question quite like this on the test, so I'm going to skip it to save us time. Good question, but there's a better question that I went over in the other video that is more like the question on the test, and that's this one right here, number 19. So spend your time focusing on that one. All right, the entire rectangle has a base equal to 22. That's a good one. So that's 22 from here to here. And a height equal to 12. So that's from here to here. If the 4 triangles are removed from the rectangle shown, what will the area of the remaining figure? So we have the large figure, which is going to be 22 times 12. And 22 times 12 is going to give you 264 too. So 264 is the whole thing. But then we got to find like what's the area of this little triangle. Well, it's a 4 by 4, so it's going to be 1/2 of 4 times 4, which is, I think it should be 8. But there's 4 of them. So this is, this has an area of 8, 8, 8, and 8. So we really got to subtract 4 of those times the 8 to get us our answer. So subtract 4 times 8, and we should get 232 square meters. The area of the smaller hexagon is 72. Find the area of the larger. Okay, so we can compare these two. So 4 to 14, that should reduce to 2 over 7. So that's my A to B. But to find areas, I need an area ratio. So if I square them, I get 4 over 49. So that's my area ratio. So I can take that area ratio, and it's small over large, and I set it equal to the actual area, 72 over, I don't know. We cross multiply, we get 4x equals 49 times 72. And we get 3528. And then divide by 4. And we get our area as 882, and that's in square inches. Okay. The area of two similar octagons are 32 and 98. What's the ratio of their perimeters? Okay, so here we have our areas. So let's simplify this first. So I believe what 2 goes into both of these, so that becomes 16 over 49. So this is my a squared to b squared, which is not my ratio of my perimeters. So to find that, I have to square root all of these pieces. And what's convenient is the square root of 16 is going to give you 4. The square root of 49 is going to give you 7, which we literally just saw up there. So the ratio of my perimeters is 4 to 7. Find the area of the kite. So we know the kite's formula is d1 times d2 divided by 2. So here I see I have a right triangle. This is 4 rad 2. It's in the L rad 2 position, which means this should be 4 and this should be 4. So diagonal 1 is 4 plus 14, which is 18. And then diagonal 2 is just 4 plus another 4, which is going to give me 8. So 18 times 8 divided by 2 should give me 72 as my area in, I don't know, square units. There we go. Find the area of a triangle. So this is where we just apply the formula. It's 1/2 b times c times the sine of a. Remember the angle is the capital, so we have sine of 25. And it really doesn't matter where the other ones go. So it's just going to be 1/2 10 times 7. You literally just plug that all in at once. But all the purple right there makes 35 times sine 25. Plug that in. We should be good to go. Final answer is 14.8, and that's in hundredths place, so 0.79 is what I should do. Square units. Boom. All right, 28, 29, and 30. Yeah, 3 more. All right, here we go. All right, so this is an octagon. So the first thing we want to find is our central angle, which is 360 divided by 8. That's going to give me 45. And then that's half of it, so that's 22.5. So it breaks it in half. So my triangle, we got 10 right here. We got 22.5 there. We got half side. And we have the apothem. And so we set up our googly eyes. We have opposite, adjacent, and hypotenuse. Okay, let's find the apothem first. We'll use red. So it's H and A, so it's going to be cosine of 22.5 equals apothem over 10. So we just get 10 times the cosine of 22.5, which is 9.2. So we get the apothem is equal to 9.2. Okay, so save that work. I'm going to erase it. So if you need to see it, pause it. But I'm going to erase it because I'm running out of space. Okay, so let's go now to blue for the half side. So we're going to look at O and H, so that's sine. So we're going to get the sine of 22.5 equals, this is going to be x over 10. So I'm going to get 10 times sine 22.5 equals, okay, so we get x equals basically 3.8. Now, that's only half of this, so I need to double it. So when I double it, I get about, so one side should really be 7.7, and then the perimeter is going to be that times 8. So a side is 7.7 right here. Then we need to multiply it by 8. And so our final answer is 7.7 times 8, which is going to give us about 61.2. And then we just have to do 1/2 Apothem times perimeter. That should give me my final answer of 281.5. And that's in square meters. So that's definitely by far one of the more challenging ones. Okay, let's move. Find the area of a regular decagon with the side length equal to 12. Okay, so decagon is 10 sides, so the perimeter here is just, it's just going to be 10 times 12, so that's just 120. If we break the decagon into that little triangle, again, to find it, we have to do 360 divided by 10, which is 36, but then half of 36 is what our apothem does, so we end up with 18 in here. The side length is 12, so this is going to become 6, and we want to find the apothem. So we set up our googly eyes. We have opposite and adjacent. So we are going to use tan. So we get the tan of 18 equals 6 over a. Switch those two. So a equals 6 over tan 18. Get 18.5, and then it's just 1/2 Apothem times perimeter. So I'm just going to do 18.5 times 120 divided by 2, and we get about 1110, and that is square units. That's a 1, by the way. All right, last but not least, we're factoring. This is going to be split the middle term. We can't factor anything out of here. 3, 7, and 6 have no common factors. So let's break this down. 3 times -6 is -18, and we want to add to 7. Okay, so let's go through our factors. 2 and 9 sound pretty good. I'm going to go with a +9, -2. And so we're going to break that down into 3x squared plus 9x minus 2x minus 6. Factor by grouping. So here it looks like I can pull out a 3x. That would leave me with x plus 3. And then whatever I pull out of here, I want it to be x plus 3. So it looks like I want to pull out a -2. And that becomes x. And -6 divided by -2 is +3. They look the same, so we get x plus 3 as one of our binomials, and then our other binomials, the leftovers in green, 3x minus 2 equals 0. So set each of these equal to 0. This one's going to be x plus 3 equals 0 becomes x equals -3, so that's a 1 answer. And then the next one, we get 3x minus 2 equals 0, so that's going to be 3x equals 2, and then divide by 3, that's 2/3. So those are our two answers, -3 and 2/3. All right, guys, that's it. Thank you.